Alrighty guys, we are going to add to our notebook. Let me zoom in though. Zoom. And we are going to talk more about the triangle sum theorem. So triangle sum theorem, which we're going to do on 35, 36, and 37. Okay, so if we turn page, we're going to add some stuff to 35. You should already have your triangle on 36. Mine's not there yet, but we're going to added that together. And then 37 over here. Okay. So on, oh geez, going too many pages. On 35, we are going to add this next one in our notebook right here. So it looks like this on one side, that on the other. So we're going to fold this in half like a backwards book. And then if we want to do a little cut right here, like that, put that on 35. And then the last one that you should have in this notes packet is this one. And these are actually different. We got our triangle sum theorem and then the exterior angle theorem. And so we're going to want to cut it in half. I guess, you know what, let's just leave it. We'll just fold it in half like a book, like this. We might not have anything fun on the cover, but we can label what it is. And so we'll put that on 37. Boop. Boop. Alrighty. Okay, so going back to 35, we talked about our triangle sum theorem, which essentially says the three angles of a triangle add up to equal 180. So our interior angle sum theorem or our triangle sum theorem, you probably already knew the three angles inside of a triangle add up to equal 180. So we're going to practice some problems like that. The less commonly known one is our exterior angle theorem. So that essentially says if we have two angles of a triangle, then they add up to equal the outside one. We actually call these two angles remote interior angle. The reason we call them remote interior angles is because they are far away from the exterior one or like not adjacent. So they have to be the two non-adjacent angles that we add up to equal the outside one. So it's important that we recognize that. And when we say that they add up to equal the outside one, it's because we like added a little tail on our triangle, which is kind of funny and weird. But yeah, once you add this little outside angle here, you can find out some interesting stuff about it. So let's try a few. So here, for this top one, we can do it pretty quickly, like 45 and 95 adds up to equal 140. And so then I need 40 more to be angle C. So you can do it quickly like that if it's super easy in your head. Now with this one here, this is interesting. So I have two triangles. Right in the middle, I have vertical angles. So like if this is 50, I know that that's 50. And so then, oh, this is interesting. So now I have two angles inside of this triangle. I always need two. And I can add those up for 90. And so then to get 180, I need 90 more. So I can put the number 90 or I could put the box. So even though it doesn't kind of look like it, that's 90-degree angle. Now what's interesting about this one over here, and we're going to talk more about this later, these two little dashes mean that the sides are equal, making it an isosceles triangle. And if two sides are the same, then two angles are also the same. So the two angles that would be the same are the ones like opposite of those sides. So since this one's 50, boop, 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 this one would have to be 50. And if that's a little weird to you for now, like don't worry about it too much. We're going to get into that more later when we talk about triangles, actually next chapter, so soon. But for this example, we can do it quick. So I have so far in this triangle, this angle is 50, that angle is 50 for a total of 100. and I need 180 to make a triangle, so I need 80 more up here. Okay, let's try a few more. This is getting crazy inside here. Alrighty, so for this one, the measure of angle ACB. So ACB, this one right here. Okay, well, if I take a look at this triangle, because I really see like 3 triangles. I see this one, I see this one, I see the whole thing. So that's kind of interesting. So I can use any of those triangles to help me. And so far I have 51 and 47 in there, plus this missing angle, which is angle ACB. We'll have to add up to equal 180. And so if we add it up here, we got 98. And so then we can subtract that off to get the measure here. So what's that? 82? 82 degrees would be the measure. Now that's helpful to me because when I go to do the next one, actually that was that one. The next one, BCD, is this one here. If I look inside that triangle, like this small one, I can't really do too much because I only know one angle. But I had this one now, and I know that it's 82. Oh, so I could do a linear pair thing. They're a linear pair. So that would mean that 82 plus angle BCD would have to equal 180 because these are a linear pair. And so then I could subtract the 82, which is just going to be the 98 that I had before, which, little preview, I mean, we talked about it, but the 2 remote interior angles will always add up to equal your outside one. So that kind of shows you why that works out. And then last but not least, we want to find the measure of angle DBC. So this one here. And I can do that now. Like if I tried to do this problem backwards, I really wouldn't be able to. I had to find ACB first because that was the only triangle that had 2 measures in it. Oh, I could have found, well, no, yes, I could have. The measure of angle DBC, I could do one of 2 ways. Oh my gosh, I'm just realizing, I'm sorry, I'm having a lot of things happen. I know the measure of BCD right here is 98 because I just found it. I know that this angle is 48, and then I want to add that with DBC because that is the small triangle, and those should all add up to equal 180. So we'll have 146 here and subtract that on this side to get 34 degrees. However, I could have, oh, this is so fun. What I could have done is looked at the whole triangle. And in the whole triangle, I have 51 degrees in this corner, 48 degrees in that corner. And then this corner is kind of 2 angles. It's the 47 and it's something that I don't know, which is that DBC that I wanted. All those things make up the triangle, so it has to add up to equal 180. And let's just see if we get the same thing. So 51 and 48 is 99. Plus 47 will be, let's see, 6 carry the 1, 146. And if I subtract that, that's the same thing. So 34. Love it. Cool. Maybe we're going to skip that one for now. We'll come back to it together. Down here, let's try some exterior angle theorem stuff. So if I have 2 remote interior angles, they can add up to equal an exterior angle. So in this picture here, I do notice that I have vertical angles, boop, boop, but I don't know either one. In this triangle, I only know that this is 90, so that's not super helpful. But in this triangle, I know that this angle here is 30 and that one is 90. So these 2 remote interior angles can add up to equal this outside one, which isn't super helpful. It's not inside the triangle, but it's something to do. So like 90 and 30 will be 120. So this out here would be 120 degrees. Sorry, I know I'm not answering any of the questions. I see numbers and I just have to do the things. Now, these angles are vertical, and again, they're not inside the triangle, but 120, 120. These two are a linear pair, and so that one would have to be 60. Oh my gosh, I could have figured that out anyways because I knew two of the angles inside of the triangle. I'm just getting too excited. So then these vertical angles are 60. They're the same. And then I could just use a triangle sum theorem, like 60 and 90 is 150, and then I need 30 more. So those two triangles have like the same angles in them. That's cute. Okay, let's see if I answered any of these questions. So the measure of angle HJI was 60. We could have done that with the triangle sum theorem because I knew two angles, so I could have found the third. Angle KJL, also 60 because they're a vertical pair. The measure of angle HJK, oh, I did need to find that one. That outside angle was 120. And then the measure of angle IJL, oh yeah, also 120 because they are vertical. And those are the remote exterior angles anyways, or those exterior angles. Okay, so another thing that we can do with our remote interior angles is like use it to solve for x. So again, these two angles are remote interior angles and they will add up to equal the outside one as long as that outside one is far away from it, so not adjacent. So we can do 4x minus 5 plus 3x plus 1. And those two angles added up will equal my outside angle, so 132. And so we can combine like terms because they're all on the same side. So we'll have 7x minus 4 equals 132. Add the 4. So we'll have 7x equals 136. And then divide by 7. Oh, I wonder if this girl's going to go in evenly. I don't think so. Nope. We'll just leave it. It has 136 over 7. Oop. Okay, I think I'm going to skip this one as well. Let's jump to the next one that we had. So on 37, we'll say that this is triangle sum theorem and exterior sum theorem examples, just so we know what we're looking at. Okay, and maybe we won't do all these, we'll just do a few, because I don't want you to feel like we're being redundant. So if we try with our triangle sum theorem examples first, I'm actually going to start with number 4. So solve for the value of x, and then list the sides from smallest to largest. We're not going to worry about that. I think all these questions say that. Don't worry about the list of the sides from. So we can ignore all that stuff. We'll talk about that later, but we don't need to know it now. So for number 4, solve for the value of x. So these 3 angles are angles inside of a triangle, and so we can add them up to equal 180 because of the triangle sum theorem. And so to solve for x, we're going to combine our like terms. So we'll have 2x, and then 84 plus 59 plus 11. Let's see, we got 70, 154. And then subtract the 154 on both sides. And so 2x equals 26, and so x will be 13. And again, we don't need to worry about that. Then what I could do is I could like plug the x back in and find each of the angles if I wanted. So maybe I'll leave it at that one. And then let's try one over here. So solve for the value of y. Let's start at the bottom. So, okay, solve for the value of y. Well, I do have all the angles inside the triangle labeled, but they're not all the same letter. So I don't really want to add those 3 things up to equal 180. However, I could add the 2 remote ones to equal the outside one, and that one would work out because they're all x's. And that's helpful to me because once I know what x is, I could either plug it in here and do like an angle pair thing, Or I could plug it in here and do like the triangle sum thing. So either way, but I do have to start by finding x, which isn't really what the question's asking for. So we're going to do our 30 plus 10x minus 10. So our two remote interior angles to add up to equal the outside one. So 12x minus 4. And so when we combine like terms over here, we'll have 10x plus 20. Then I want to get my x's on the same side, so I'm going to move the smaller one. So we'll have 20 equals 2x minus 4, and then I'll add my 4. So 24 equals 2x, so x is 12. All right, I think I'll leave it at that, and maybe we'll try some more of these examples together tomorrow. We can do all of them, some of them, none of them, whatever you guys need to do. If you maybe want to try some on your own, and then when we come in to class, we can kind of check them together. That would be fine too. Good luck.